discussion from the eighth live session that was concluded last week in a brief manner. Then we will go through the discussion of week 9 content in a much simplified manner, and in between, I will try to provide you some question relevant to the content. So in week 9, we discussed about mainly the week 9 content was supposed to discuss about about the retrofitting and repair of masonry structure. So in today's session, we will recap the introduction to masonry structure, overview of types of masonry, distresses in masonry structure, evaluation of masonry performance, and finally, we'll see different repair techniques for masonry structures. Once we'll go through the discussion, we'll conclude the learning drawn from the interactive session at last. So, in the last live session, we started discussing pavements. So, what are pavements? They are basically these are basically structures that carry footloads or vehicular loads. They are broadly classified into two categories: bituminous pavement and concrete pavement. The major difference between the two is that in the former one, in the bituminous pavement, bitumen is used as a binder, while in the latter one, cement is used as a binder. There are several other differences also, like load distribution. In bituminous, it is a grain to grain transfer, while in concrete, it is through slab action. The number of layers also vary between the two pavement, which dictates their performance and failure, which can be seen in the images also on your screen. Now, after the basic introduction, we looked into distresses in pavement. Here, we talked about different reasons for distresses. These were repetitive loading due to moving vehicle, overloading of vehicle, temperature and moisture effect, subgrade failure, deep foundation movement, material degradation, joint failure, and improper mix design and compaction. We also saw how we classify and identify these distresses in both bitumen and concrete pavements. There can be different types of distresses in terms of their visuality. So a few of these are shown on the slide here. Like you can see cracking, settlement, crazing, spalling, wear and tear, and map cracking. We saw in detail about various types of identification of distresses. Then we talked about how we evaluate pavement performance. So performance can be classified into two categories: functional performance and structural performance. For evaluation of function performance, we have visual inspection and instrumental inspections like straight edge measure, bump integrator, and profilometer. While for evaluation of structural performance, we have semi-destructive testing like core extraction and testing, trial pit assessment, and entities like falling head deflectometer, for which we saw in brief how it works. So we saw how at one point the load is applied, and using different sensors, geophone sensors, we record the deflection away from the load, and from the profile of obtained deflection versus time, how we can back calculate the performance of a pavement. Now, after quantifying the performance, there comes repair, for which we discussed concrete overlay as a repair strategy. We saw different types of concrete overlay possible for bitumen and concrete pavement. These were like bonded, partially bonded, and unbonded concrete overlay, which were for concrete pavement. And for bituminous pavement, we saw conventional thin and ultra thin white topping. Here, the choice of overlay is majorly governed by the extent to which the existing pavement is deteriorated, for which we saw a detailed discussion. For bonded and unbonded overlay, we saw how stress distribution work. Okay. We talked about design consideration that are information needed that we need before making a choice of overlay, and we talked about application of concrete overlay, in which is divided into four steps. First, making the choice of material. Second, making choice of ingredient that is required to make that material. Third, pre-overlay treatment that may be required based upon the type of overlay we are providing. And finally we saw paving of overlay, how overlay is placed. Okay. So in this, we saw in brief each step. So first we saw how the overlay can be placed through fixed foam concreting and movable foam concreting. Then we saw how they are leveled and how texturing is done and how joints are placed on the pavement, and finally how finished surface look after concrete overlay treatment. Okay. This was all from the last week's session. Now, in the discussion that we had till now, we have covered major concrete structures and pavement for repair and retrofitting. Today, we shall start with a new category and the one of the oldest mean of construction, that are masonry structures. So, a masonry structure are the oldest building material that still finds wide use in today's building industries, and the most important characteristics of masonry structure is their simplicity. Okay. Uh, Masonry, how we define a masonry? So masonry is basically a heterogeneous material which consists of units and joints. So by units we mean, units are bricks, blocks, ashlars, adobes, and irregular stones. So these are known as units, and the joints consist of mortar, which can be clay, bitumen, chalk, lime, cement based mortar, or glue. Okay, combination of these two makes a masonry. Now there can be a huge number of possible combination can be generated using these two material, and these combination they vary based on geometry, nature, and arrangement of unit, as well as the characteristics of mortar which are possible in masonry. So based on these parameters, a large number of masonry combinations are possible. Okay. As we can see this through the images also, like in case of stone masonry there can be different types of masonry like rubble masonry, ashlar masonry, and coarse ashlar masonry, based on the shape and the arrangement of stone. While in case of brick masonry, the arrangement of bricks can generate different kinds of geometries, like we have English bond, Flemish bond, and stretcher bond. Okay. The same can be visualized in these images also, where when we go from a microscopic level to macroscopic level, we can see how brick units and mortar joint assemble together to form a composite structure. While a few application of brick masonry can also be seen in these images, like you see confined masonry with thick bricks that are mainly used in areas where seismic activities are very critical. Here you can see masonry units that are used in Switzerland, and here you can see masonry units used in USA. Okay. So masonry can find different kind of geometry or different kind of combination based on the arrangement of their two basic units, which are units and joints. Okay. Now, masonry structure based on the units that we are using are mainly classified into three categories. We have brick masonry, stone masonry, and concrete masonry. So, when we talk about brick masonry, these are most popular form of masonry. Here, bricks are generally used as a unit, while joint can be of any composition of mortar. So bricks are typically made using clay, sand, water, and sometimes lime or ash also, which when mixed and shaped and are kept in ultra hot oven and baked into solid units. So this is how bricks are made. Okay, brick masonry often take on a serpentine masonry, which means that the lines included don't follow a straight line. Instead, they form a staggered pattern, which gives them more strength. So, we have seen generally in case of brick masonry, like we saw in this images also, there is not a single line over which the bricks are placed. It has a staggered arrangement. Okay, and this plays a major role in the strength of brick masonry because it helps in crack arresting. Okay, so you can see in all the three types of brick masonry we saw, there was not a single line in which the bricks were arranged. They were in a staggered arrangement. This is known as serpentine masonry. Okay. Now, second, we have stone masonry. These are also one of the oldest form of masonry. Okay. Two types of stone can be used to create stone masonry. There can be either dressed stones or undressed stone. So, undressed stone are roughened surface stone with the uneven size and pattern, which are laid as rupple masonry, while dressed stone are more regular size and pattern stones, which are often used in modern stone construction. Okay. So here you can see the example of both. So these are undressed stones, okay, masonry, and these are more kind of a dress stone masonry. And from the images also you can, from the images only you can see undressed stone provide a more authentic and natural appearance, which might sound messy but offers a great looking result. Okay. Final categories are the concrete block masonry. So here concrete is laid similar to brick, with one cinder block being pressed at top of the other in a staggered formation. So here also staggered formation is used for placing the concrete. Okay, since concrete block are much larger than brick, they takes far less time to lay them, and they tend to be more affordable, and they are also fire resistant. So these are some of the major advantages of using a concrete block over a brick masonry, and that's why it is forming more application in recent times. Okay, so here in this images also you can see this is an example of a brick masonry building that you can commonly find in rural areas, while you can see here a concrete masonry arch kind of architecture that are often used in modern constructions. Okay. Now, though masonry is used for a long time and are often assumed to be more durable compared to concrete, they often undergo distresses. Okay, over time, and there can be several reasons behind the degradation. What are these reasons? So these reasons include settlement of foundation beneath the masonry structure, which can lead to cracking and distortion in masonry walls. Okay, second reason can be moisture, due to which water infiltration can occur through cracks, and inadequate waterproofing can lead to efflorescence, spelling, and staining in masonry. There can be thermal movements due to temperature variation, which can cause expansion and contraction, leading to cracking and displacement in masonry. Chemical reactions can also be a form of distress in masonry. When a masonry is exposed to acid or salt, it can cause corrosion of masonry material, which can weaken the structure. An overloading of structure can again be a reason for distress in masonry, where excessive load or improper distribution of load can cause overstressing in masonry, resulting in cracking, bulging, and collapse of masonry. And poor construction practices can often lead to distress in masonry, like if we use deficient construction techniques such as inadequate bonding between the motor joints between the units, or improper mortar composition, or lack of reinforcement. These all things can cause weakening, structural weakness, and lead to failure in masonry structures. Aging and wear is also one of the most common form of distress in masonry, where natural degradation over time can occur due to weathering, aging, and wear, which can lead to degradation of masonry material and weakening of structural integrity. Biological growth is also one of the very common form of distress in masonry, where growth of vegetation such as moss, algae, and ivy on masonry surface promotes moisture retention and physical damage to structure that you can often see in old heritage structures. And finally, we have earthquake, where seismic activity can induce shaking and dynamic forces which can cause cracking in masonry, leading to displacement and collapse of masonry structure. And this is very critical in masonry. Why? Because masonry units are weak in resisting the lateral force. So earthquake can be a very severe, critical form of distress in masonry structure. Okay. Now, so these were like around 9 to 10 different reasons, like in how distress can occur in the masonry structure. But just knowing the reason for degradation is not enough. We also need to know how degradation causes distress and how this distresses appear on the masonry structure, so that as a consultant we can decide a suitable repair method. Okay, so let's see some examples of how distresses appear in the masonry structure. So distresses can appear in the masonry structure in different forms. So you can see step cracking or diagonal cracking in masonry, which mainly occur due to the foundation movement. Okay, so as the support for masonry wall settles or deflect, the masonry attempts to follow it, and this movement leads to step cracking. See in the images also you can see a step cracking kind of distress has happened on the masonry, and these distresses are mainly due to foundation of the settlement of the foundation beneath the masonry. Okay, there can be vertical cracking, which you can observe in the masonry structure, and these are mainly due to moisture shrinkage. Then there can be cracking resulting from stress concentration in openings. So often you see near the windows or near door joints, there can be a diagonal crack that appears, and these cracks are due to stress concentration occurring at the near the opening. Okay, there again there can be vertical cracking in the masonry, which can be due to mainly the excessive loading or deflection in the masonry due to temperature gradient. Okay, then there can be different kind of leakages and stains that appear on masonries, like water leakage can appear on the masonry structure like this. Efflorescent stainings can be seen on the masonry. Damp patches can be observed on the masonry. Subfluorescence action can appear on the masonry. Crystallization of salt can appear like this on the masonry. So these are different forms of minor distresses and how they appear on the masonry. There can be compatibility issues also, which can appear like this on a masonry structure. Here you can see cement mortar and lime mortar, they are not being so compatible, can lead to cracking near the joints. And you can also observe fusion throat deterioration in the form of longitudinal cracking in the masonry. So this is how we can identify different types of distress in the masonry. If there is vertical crack, if there is diagonal crack, if there is step cracking, we can, by visualizing the crack, we can guess what can be the reason behind that cracking, so that we can make an appropriate choice of what repair method we need to go forward with. Okay, now, once we know the reason behind the distress, for making the appropriate choice of repair, we need to know the intensity of degradation also. And this can be done by evaluating the performance of masonry structure. Okay, so the evaluation can be done in three ways, either through visual inspection, or using non destructive testings, or using destructive testings. So let's see each of them one by one. Okay, so first we have visual inspection. Okay, so as we have discussed throughout the course, visual inspection is the simplest and the most widely used method for evaluating masonry, and it involves a thorough inspection of structure to identify visual signs of distresses such as crack, bulges, spalling, staining, and biological growth. Now, we saw in the previous few slides how a distress can appear on the masonry. So, by conducting a visual inspection, we can see what kind of distress is there on the masonry, and we can judge what can be the reason behind that distress, which can be an important part for evaluating the performance of a masonry structure. Okay, so suppose you see a diagonal crack, step kind of cracking in the masonry, then you can guess that there can be some issue with the foundation. So for evaluating the performance of masonry, you will go towards evaluating the properties of the foundation, which can help you to make a quick judgment of what repair technique you need to go forward. So in this way, visual inspection can play a vital role in evaluating the performance of a masonry structure. Second reason can be second method for evaluating the performance is non-destructive testing. So these are commonly used for evaluating severity of distress in a masonry structure without causing damage to the structure. As the name suggests, it is a non-destructive method. Okay, these testing are often referred as a stress wave technique, where sound wave or mechanical waves are used to evaluate the structural performance. So since it is a non-destructive technique, what we do in most of the entities, we send a wave in the structure, and we see how the wave is propagating through the structure, and based on the properties of wave we just evaluate the structural performance. Okay, so this is the basic principle behind a non-destructive testing. Okay, now for masonry structure, non-destructive technique that are used are of four types: ultrasonic pulse velocity, ground penetrating radar, infrared thermography, and impact echo testing. Okay, now how these four types of entities work. Okay, so in case of ultrasonic pulse velocity, we measure the speed of sound wave passing through a masonry to assess the integrity and detect defects such as voids, crack, and delamination. So in this, we use sound wave, okay, to assess the masonry structure. How we will see in the next slide when we will see the diagram. Okay. Then we have ground penetrating radar. Here we use radar pulses to penetrate the masonry and detect anomalies like cracks, voids, and moistures and reinforcement. So here we use the radar pulses. These pulses penetrate through the masonry and it helps us to detect the any kind of distress in the masonry. Third, we have infrared thermography, where we measure the surface temperature variation to detect anomalies such as moisture infiltration, thermal bridging, and delamination. So, in case where moisture and thermal are the reasons, moisture and thermal issues are the reason behind distress in masonry, in IRT can be used for evaluating the performance of masonry. And finally, we have impact echo testing, where this testing involves tapping the surface of masonry with a hammer and analyzing the resulting acoustic response to detect the defects such as void, delamination, and debonding. So, in this, what we do, we send a mechanical wave through the masonry and we assess the performance of masonry. Now, just by reading what a testing does, it doesn't clarify a lot about how it is working on field. Okay, so let's look in these testing through images also so that you can get a better clarity. Okay, so first we have a UPV, ultrasonic pulse velocity, where we have two sensors. This is transducer and this is receiver. Okay, and this is a masonry block. This can be a masonry block or a concrete block. So what we do, these transducers are made of PZT material, piezoelectric material. Okay, what does a piezoelectric material do? It converts electrical signal into a mechanical signal, which can pass through the masonry, and once these signal pass through the masonry, the PZT again converts the mechanical signal into electrical signals, which can be read by us. Okay, now how this can be used to detect performance of masonry? So higher is the density of the medium, faster is the wave propagation. So if there is any defect that is present inside the masonry, it will lower the speed of wave propagation, which can be monitored by us in the display unit. Okay, so here you can see we have generated an electrical pulse. We send this pulse to the transducer. Okay, this PZT converts the mechanical wave into electrical, this electrical signal into mechanical signal. Mechanical signal passes through the masonry. They are received at the end, which converts these mechanical signal again into electrical signal, which we read and we compare to check if there is any defect or not. Okay, so this is how a UPV work. Second, we have GPR. Here again we input a wave. So you can see using a transmitter we input a wave into the concrete or a masonry, and the presence of crack or defects reflects the wave, which can be monitored by the receiver. Okay, so here you can see a movable GPR device. Okay, it will regularly transmit a wave, and it will record the reflected wave also, and based on the time the wave took to reflect back, we can judge if there is any defect in the masonry or not. Okay, third is IRT. So here what we do, we heat signal is used as an input, and the radiation coming out from the masonry is used to map the defect. Okay, so you can see here we have an external heat source, okay, which is heating our masonry block. Okay, and the emitted radiation, it is captured by our IR sensor, and this when feed to a computer system is used to make a heat map of the structure, which is used to detect any presence of voids. So you can see the same in the image also. So it is this IRT is like a camera. Okay, so here the dark blue patch mark shows that there is some abnormality in this structure. Okay, and by this we can also know where the location of the abnormality is and how intense is that abnormality. Okay, so this is how IRT works. Okay, finally we have impact eco testing, where we use a small impact, we make a small impact. Due to this impact, mechanical waves are generated. Okay, these waves will try to pass through the concrete sample. Now the wave can be reflected in two ways, either from the end of the sample or from the defect level. So based on the reflection of the signal of the wave which is recorded by the transducer, we can judge whether there is a defect or not. Okay, so we have given the input mechanical wave, and from the output spectrum we can make a judgment of the presence of defect or any kind of abnormality in the structure. Okay, so these this is how different entities work. So the basic is sending a pulse and receiving the pulse and checking the variation in the pulse to detect the presence of any defect. Okay, now after non-destructive testing we have destructive testing, where first is core sampling and testings. So this is something that we have discussed quite a few times when we talked about evaluating the performance of any structure. So, in core sampling, it involves extracting a cylindrical sample from masonry wall or elements for laboratory analysis. And this can provide information like material properties such as compressive strength, density, and moisture content. Okay, so what we do, we collect a core, we drill a core from the masonry structure. Like this we are drilling a core using a core drilling machine. Okay, and we collect this core and we test this core in laboratory for inspecting the performance of masonry. So these inspection can be the compressive strength, flexural strength kind of thing, or we can collect powdered samples also from the masonry, for which we can conduct petrographic examination or moisture content analysis, which can also be a type of assessment, destructive assessment of masonry. Okay. And second, we have pull-out testing, which can be used to evaluate the bound strength between the masonry unit and the mortar, or between masonry and the reinforcement. And this involves applying tension to the embedded anchor or reinforcement to assess the anchor capacity. So this we saw in the previous live session also. We have reaction forces, rings that are placed across the a needle that we have penetrated inside the structure. We pull this needle off and we see how much force it was needed to pull this needle off. Based on the force required to pull this needle head out of the structure, we can judge the bond strength of a masonry. Okay, so this is how the setup of a pull-out testing look, and here you can see a pull-out testing was carried out to judge the bond strength between a brick and a mason mortar unit. Okay, in a brick masonry. Now, once we know the type of defect, reason behind the defect, and intensity or severity of defect, we can go forward with making the choice of either repair or retrofitting. Okay, so repair and retrofitting damage repair and retrofitting of damaged masonry often involves combination of several techniques which are aimed to restore the structural integrity, improve durability, and enhancing the seismic resistance of the masonry. Okay, now different repair methods for masonry are classified into following types. So we have masonry repointing, we have crack stitching, we have grouting, we have reinforcement installation, we have surface coating, we have anchor installation, we have structural strengthening, and seismic retrofitting. So these are various methods in which a masonry can be repaired. Okay, among these, grouting we are well familiar from our past discussion, thus we won't again emphasize on that. So in grouting, we inject chemical or epoxy-based mortar through nozzles into a crack to fill the crack, and then we use sealant from the top to seal the filled crack. Okay, and this helps us to regain the original performance. So the detailed discussion upon of different types of grouting, different methods of grouting, we have already done in the past session. So won't repeat that. But still, if anyone has any doubt regarding routing, they can post their query in the chat box. Okay. Today we'll see other methods listed in this table. Okay. So first we have masonry repointing. This is very commonly used repair method for masonry structure owing to its simplistic application and effective performance. So what is masonry repointing? It is a form of joint repair method, and it involves removing deteriorated or damaged mortar joints and replacing them with a fresh sound mortar, and this is done to improve the structural stability and weather resistance. Okay, so here you can see in this image there are severe degradation of the mortar lining that happened due to weathering. Okay, now this degradation in mortar lining, what it will do, it will weaken the structure capacity. So masonry repointing was used as a repair method. So in this, what we do, we prepare a mortar paste, okay, and we fill this masonry again. This is called repointing. Okay, so once you will fill this masonry joints again with the mortar, it will help to stabilize the masonry structure, which will be able to take the initially defined load level. Okay, so it is a kind of repair method. Okay, we are repairing the structure to its original state. Okay, it is a repair technique for masonry. So here you can see in this image also, due to cracking, since my brick is much more stronger than the mortar lining, generally cracking propagates along the mortar lining, which can lead to deterioration of mortar. Okay, so if we will repoint this mortar lining, we will observe that before cracking and after, before repair and after repair, my structure integrity will change like this, and now my structure will be recovered to its original state, and it will be able to perform its intended function without any kind of problem. Okay. Second is crack stitching. Okay, this method is again very common to and very similar to what we have discussed in the initial live sessions where we talked about stitching and stapling. Okay, and this again is very commonly used repair method for both longitudinal and vertical cracking. So any form of cracking, crack stitching is a very commonly used method. So how this method work? Okay, so crack stitching is a masonry repair method for repairing cracked wall and ensuring that they are reinforced, and it involves retrofitting several crack stitching bars which are grouted across the cracks in wall to reconnect them and provide them stability in the masonry. So in crack stitching, what we do, we have a crack. Okay, so across the crack we make a drill, we drill the concrete and we insert a reinforcement bar and we grout that reinforcement bar. Now what this does, this uh, stitching, it arrests the crack and it stops its further propagation, and it strengthens the masonry from the weaker area. So in this image you can see across the length of the crack, uh, like horizontal drilling was done, and in the those drilled hole rebars were inserted, and these rebars were later filled with the grouting material. So this will help me to arrest the cracking. So in these images also you can see how crack stitching activity has been carried out for masonry repair. Okay. Third, we have reinforcement installation. Okay, this is used to strengthen the lost load bearing capacity of the structure by providing a type of confinement to the weak areas to resist stresses. Okay, and these types of repairs are generally opted for corner distresses, like near windows or near door corners. Okay, so in such cases, reinforcement installation is commonly used as a repair method. Okay, now there are two types of reinforcement that can be used: either steel reinforcement such as steel bar or mesh within the masonry walls, or elements to enhance the structural strength or ductility we can use as steel reinforcement, or we can use fiber reinforced polymers also, where bonded FRP composites such as carbon or glass fibers are used to improve the flexural strength and shear strength of a masonry as well as seismic resistance. Okay, so here you can see a masonry wall which was severely degraded. Over that wall a steel mesh was placed, and over the steel mesh cement grouting was done, so that my steel mesh can confine the masonry and it can strengthen the masonry. Okay, in this image also you can see a concrete block kind of masonry. It was repaired using a steel mesh at the corner of the door joint, and it was covered with a uh, concrete mortar patching at the top. Okay, so these are generally used for strengthening the masonry at the edges, which may be critical in seismic damage or seismic prone areas. Okay, then we have surface coating and treatment. Here, based on the distress reason, there are three types of coating that can be used. So these are waterproofing coating. So applying a waterproof coating like sealants or applying waterproofing coating sealants or membranes to masonry surface to prevent moisture infiltration, moisture related damage. So waterproofing coatings are used when moisture infiltration is the reason behind the distress. We have anti-corrosion coating, which involves applying and corrosion resistance coating or paints to protect masonry elements from chemical degradation or environmental exposure. So in these regions where acid attack can be a formidable reason behind the damage to a masonry, anti-corrosion coating is used. And we have biocide treatment, where we apply biocides or fungicides to the masonry surface to inhibit the growth of algae, molds, and mildews. Okay, so here you can see in this in these images, siloxane based water proofing was used on the masonry structure which was prone to moisture ingress, while a prom 50 masonry biocide was applied here in this masonry to resist the growth of algae and fungi which can lead to distress in masonry. Okay. Fifth is anchor installation. So this is generally used for repair of arch masonry. So here it involves installing anchors to secure additional structural strength or attachment to masonry to ensure proper load transfer and structural stability. So in this, what we do, we drill a hole perpendicular to the direction of cracking, and we insert and grout the steel rebar, which will resist the further propagation of crack and will strengthen the masonry also. So in this image, you can see arch masonry which had a like surface defect, like a horizontal defect. Across the length of the defect, a hole was drilled and a rebar was inserted to arrest that defect. Okay. Apart from this perpendicular repair, we can also use arch installation for joining the old and the new masonry. Like you can see here, through and through arching was done to retrofit a weakened masonry structure by attaching it with a new masonry unit. Okay, so this can also be a form of arch installation. Okay, then we have structural strengthening. Okay, this is mainly a form of retrofitting of masonry structure, and this involves enhancing the load bearing capacity and resistance of masonry structure to through techniques such as adding external support, introducing composite material, and altering structural configuration. Like you can see in the images, this is carried out by installing the external reinforcement, like you can see here in this hotel masonry building. Okay, an external horizontal rebars were installed across the length of the masonry units to support the existing masonry. Okay, which will in turn strengthen the masonry to take more load capacity, more load. While you can see here, the span length was decreased to lower the load concentration and increase strengthen the masonry units. Okay, so this we have discussed earlier also when we talked about flexural strengthening of infrastructure, how span reduction decreases the bending capacity, bending load on the infrastructure, and how it increases the strength of the infrastructure. Okay, Finally, we have seismic retrofitting, which are often used for masonry which are severely damaged due to seismic events. Okay, as the name suggests, these are opted for earthquake induced distresses, and this involves modifying the existing masonry structure to improve their resistance to seismic forces and reduce the risk of collapse, damage, or damage due to earthquake. Okay, and this involves adding different reinforcement, strengthening connection, or by introducing dampening devices. So, here you can see different examples using which masonry structures can be repaired for seismic retrofitting. So here you can see in this brick masonry, carbon fiber wrapping was applied on the masonry walls, okay, to reduce the lateral movement of the masonry and strengthen the masonry against the seismic retrofitting. In the second image, you can see retrofitting of internal wall was carried out after plaster removal and grid using rebar grid technique and application of a thicker plaster. So in this, what was done to increase the lateral strength of the masonry? A rebar grid was installed over the masonry walls. Okay, and the plastering was made thicker. Now, what this will do? It will increase the load carrying capacity of the masonry, and as the load carrying capacity of the masonry will increase, the stresses that are generated due to earthquake event, it will be reduced and my structure will be able to bear the seismic event. Okay, now, third is seismic retrofitting that are done near the doors and the windows gaps. So we know these areas, like the joints of the doors, they can be very critical for stress concentration. So different kinds of retrofitting repairs can be carried out near these joints also. So using steel plate or steel meshing, so that these critical areas for seismic failures can be strengthened. Okay, and we have additional of shear wall to enhance the lateral capacity of the masonry. So often what is done to increase the lateral strength of the masonry, a additional shear wall is casted within the masonry building. Now what this shear wall will do, it will resist the lateral force by reducing the horizontal deflection of the masonry, and thus enhancing the strength of the masonry against the seismic events. Okay. Now, this final type of repair, these are most often used in regions where seismic events are very critical. Okay, so based on the intensity of seismic event, we can use any of these type of repair for masonry structure. Okay, any doubts in the discussion till now? So we started with discussing what is masonry, what are different types of masonry, how a distress happen in masonry, how we visualize distress in masonry, how we evaluate the performance of masonry, and how we repair the masonry. Any doubt in the discussion till now? Could you please tell about the trace of stiffness matrix? Actually, I went a little away from what was discussed in week 9 content, because this course, it is more focused on the retrofitting and repair method, and if I will go into more of a structural dynamics things, it won't be justifiable to the course content. So these all things like stiffness matrix and how we form stiffness matrix and all those things, these are a separate, this is a part of a separate course. So you can look into that course also, like structural engineering. This is a part of a structural engineering course that I didn't take into account in this session. My major focus for this session was to tell you how to repair a masonry structure, because that was not covered in the NPTEL sessions. So if you will see the NPTEL recording of week 10 also and week 11 or week 12 also, there how we can repair a masonry structure won't be discussed. Okay, so you, through this live session, you will get a clarity about that. Okay, this course was intended to tell you about repair and retrofitting methods, so that's why I stick to that discussion in this session. Okay, If you want to know about what is stiffness matrix and the trace of stiffness matrix and all those things, you can go for the that particular course. You can see some of my recordings also. I have taught structural dynamics in the past for some of the NPTEL courses also. You can look at them if you want to know more about these matrix and how to solve those matrix. Okay. Please, what length of reinforcement is required when we do stitching, and how did should you drill? Okay, so basically, the length of reinforcement is not like predefined criteria. Okay, but it is often said that across the length of the crack, you need to have a equal distance from the crack. Okay, so suppose this is my vertical crack that I see in the masonry, so I need to drill the hole such that this distance is equidistance from the crack. Okay, so here you can see they have used 500 distance. Okay. Now based on the severity of cracking, you can increase this distance also, you can decrease this distance also. So suppose you see a very fine crack, you can lower this distance from 500 to 100 also. But if you see a very wide crack, you can increase this distance also. Okay. And be regarding the depth of this drilling, it depends upon the dimension of the reinforcement that you are using. If you are using 20 dia reinforcement, then you need to drill a hole of 20 to 22 mm. If you are using a 8 reinforcement, then you need to drill a hole of 8 depth. Okay, and that too will be decided based on the severity of cracking. Okay, so these are just a side practice. Okay, based on the severity of cracking, you can change the uh, length and the depth of the cracking. Okay, that thing I will see once again. Sir, in week line upload is not much with now lectures and videos and house input. Mr. Vijay, I am not clear what you are trying to say. Sir, in week ninth uploaded videos and knowledge. Okay, that's what I'm saying. Now, in week nine, it is not continuing the course. It is like going a little. It is deviating a little from the course. That's why I today in the today's session I talked about more. I talked more into the repair of masonry structure. What the content that you see that is uploaded on NPTEL in week nine, it is much more like a revision that we already know from the past weeks. Okay, regarding this question, week 9 question 7, it is related to stiffness matrix. So after class I will look into that question and I will give you a hint how to solve that question. Okay, can we get a sample of real life retrofitting project report? Maybe at the end of this course. Okay, when I will take an additional session, I will give you one example of how retrofitted project report appears like. Okay, once we discuss all different kinds of retrofitting method, we'll try to look into that report also. Once I will try to find an example like that. Okay, by the time you are asking your queries, I will just move ahead. Okay, so let's see a problem where we would be presented with few distresses images and we need to suggest our opinion what is the ideal way to repair these masonry damage. Okay, so like those you who have doubts, they can still write in the chat box, but for those who don't have any doubts, okay, regarding this session, just try to look at these images and such in the comment section, tell me what kind of repair method you will go forward for these masonry damages. Okay, I will freeze my screen here right now and I will mute myself for a couple of minutes. You can carry on writing your queries in the chat box and you can also solve this question in the meantime. Okay. Uh, that is mostly based upon the site experience. Okay, number of stitches, it can be like decided based upon the length of cracking. Okay, so suppose you have a crack of say 500 long vertical cracking you have. Okay, so you can provide suppose like stitches at every 100 interval, so you can go with the four stitches or five stitches. So that is generally that definition of how many stitches to provide, which kind of rebar to use, that all comes with practice. Okay, there is no thumb rule that is defined anywhere, like how many stitches we require. Okay, these all things are generally carried forward by experience. Okay, so let's see the solution now. Okay, so in the first image, we can see a very minute crack in the joint part, okay, in the mortar parts. So this can be repaired simply by grouting. Okay, we can use a epoxy grout or a cement mortar based grout to repair this distress. Okay, so this is mainly a repair type. Okay, say in the second image, we can see the mortar lining has been severely damaged at several locations in this chimney. Okay, in this masonry structure. So what we can do, we can go forward with masonry repointing. So we can do repointing of all these joints, which will help me to stabilize this masonry structure again. Okay, in the third image, you can see several dam patches that are appearing on the masonry structures. Okay, now these dam patches can be due to water erosion, or due to chemical attack, or due to algae formation. Okay, so based upon the environmental condition, what we can do, we can choose a proper surface coating. Okay, it can be in this image, the reason for distress was due to moisture ingress. So we can show a water repellent chemical coating on the top. We can use that coating to repair this masonry. And additionally, the lost bricks that we are able to find in some places, we can also repair these bricks also. Okay, in the fourth image, you can see a vertical crack that is there in the brick masonry. Now, stitching here can be very difficult. Why? Because it is very close to the edge. Okay, so either you can go for very small stitching. Okay, okay, or you can go for grouting of this crack. So both methods are possible for repair of this masonry. Okay, any doubts in these four types of repair? In the meantime, we let's see two more cases. Okay, so these are two more masonry structure which have undergone severe damage. So try to judge which type of repair we can use for these masonry also. And in the meantime, if you had any doubt in the first four images, you can ask them also in the chat box. Okay, so let's see the solution for these two questions now. Okay, So in this first kind of masonry, you can see there is a critical failure near the joint. Okay, so this can be a door, and above that door you can see collapse of masonry bricks that is happening due to deflection in this beam. Okay, so what you can do, you can go for uh, three kinds of repair in this case. Okay, one is by providing an external support, okay, to this beam so that it can carry the load. Okay, by either reducing the span length or by reinforcement, providing a horizontal reinforcement, external reinforcement to this beam. And secondly, to you can fill these cracks, okay, so that there is no further damage to the masonry units. Okay, so you can grout these cracks, so you can even stitch these cracks so that these cracks are stabilized, or you can even carry out external meshing near the edges also, so to reduce the increase the strength of the the joint. Okay, so there can be different types of repair that you can choose here based on the demand. Okay, and here you can see the arch masonry has undergone cracking. This can be due to settlement, ground settlement also such crack can appear. So what you can do, you can do grouting followed by anchor installation. Okay, so you can grout this crack, and then you can go for an anchor installation to stabilize this arch again. Okay, so this can be a repair method that you can use in this case. Okay, any doubt in these two images? You can also go for jacketing of crown of arch. Yeah, that is also an option. Okay, so the choice of repair, it can vary from person to person. Okay, that judgment the consultant needs to take. I give my opinion, it can be different from one person to another person. Okay, the choice of repair material or the repair technique you need to do based on the economy and the severity of cracking. Okay, and what is possible there on the structure. Okay, so this was all for today's session. So in today's session, we discussed about masonry structure, where we started with a general introduction and types of masonry structure. Then we looked into different types of distresses in masonry and how we identify these distresses. Then we discussed about performance evaluation of masonry to know the extent of degradation. In this, we saw visual inspection, semi-destructive testing, non-destructive testings, and destructive testing. Not semi-destructive, visual inspection, non-destructive testing, and destructive testings. And finally, we discussed about different repair techniques that are possible for masonry repair or retrofitting, ranging from crack repair to seismic retrofitting, and we saw a few examples for that. Okay, so this was all for this week.